Let's continue with the layout geometry for the reducer components. In this lesson, we'll add the layout geometry for the remaining components of the reducer. Finally, we'll create several collections, sets of geometric objects. This will allow us to quickly select the objects without having to select them one by one in the tree or in the graphic area. Create a sketch on the ZY plane. It will be the internal cavity sketch. Add a circle with its center at the origin. The circle diameter is 338. Add a rectangle. Merge its upper side midpoint with the origin. Its height is 265. Its width is 252. Exit sketch mode. Rename the sketch to internal cavity sketch. Click Extrusion Surface. Set the distance to 149. Turn on the Symmetrical option. Close the surface. Rename it to Internal Cavity and confirm the command. Create the sketch of the outer contour on the ZY plane. Add a rectangle. Merge its upper side midpoint with the origin. Set the height to 278. The length to 349. Create an arc with its center at the origin. Exit sketch mode. Rename the sketch to Outer Contour Sketch. Start the Extrusion Surface command. Select the sketch regions at the section. Let me delete extra object. Select the To-Object method. Select the vertex of the internal cavity as the object. Set the offset to 5.5. Turn on the second direction and repeat the same for the opposite side. This option allows you to cut off the extrusion element by a plane passing through the specified vertex, perpendicular to the extrusion direction. In this case, the element has a planar end, regardless of the shape of the section. In our case, it will have no effect. Rename the surface to Outer Contour. Confirm and stop the command. I haven't closed the surface. Let me edit the surface and close it. Confirm. Now it's OK. Create a sketch on the end face of the outer contour. Add the shift hole with a diameter 90. Exit sketch mode. Rename the sketch to shift hole 90 mm. The next sketch will be on the ZX plane. This sketch will include the geometry of the flange used to join the housing and the cover. Create a rectangle with its center at the origin. Set the width to 405, the height to 216. Add a circle with a diameter 12. The horizontal distance between the circle center and the origin is 188. The vertical distance is 40. In version 24, you can create parametric arrays of geometric objects. Start the Array by Grid command and create an array of the circles. Adjust the parameters. Set instances by direction for the first direction to 2, distance 1 to 376, instances by direction for the second direction 2, distance 2, 80. I need to change the direction. Confirm the command. Add a point. The horizontal distance between the point and the origin is 112. The vertical distance is 100. Let me adjust the dimensions a little. Create an array by grid using the point as the object for copying. Set instances by direction for the first direction to 2, distance 1 to 224, instances by direction for the second direction 2, distance 2, 200. Change the direction if needed. Confirm the command. If you go to the Variables panel, you'll find variables allowing you to control the array parameters. Let's change a number of copies, for example. You can see how it works. Let me return the number of copies. Exit sketch mode. Rename the sketch to flange. Go to the Solid Modeling toolbar set. Let's add a boss onto the face of the outer contour using a new functionality, the cone by center of base, diameters and height. The snap point will be at the intersection of the wheel axis and the outer contour face. The z-axis is perpendicular to the face. Set the base diameter to 223, the diameter to 215, the distance to 48. Confirm. In the cone, we'll cut a hole using the cylinder command. Set the result to subtraction. The snap point is at the center of the cone's small circle. The z-axis is perpendicular to the cone face. Select it in the graphic area. Set the diameter to 150. For the height, select through all. I need to change the direction. Open the Application Area section. Turn on Selected Objects. We need to create a hole only in the cone. Confirm and stop the command. Let's return to the driven shaft and edit it. Select the toroid design type. Confirm. We've finished the layout geometry creation. I'll save my work. Now we'll create geometry collections. It will help us to insert the layout geometry into the reducer assembly. For the first collection, select the wheel axis, the wheel sketch, the wheel body, the driven shaft sketch, and the driven shaft surface. Enter the name Worm Wheel. Confirm. Select the worm plane, the worm axis, the worm sketch, the worm body, the worm shaft sketch, and the worm shaft surface. Enter the name Worm. Confirm. Now select the sketch and the surface of the internal cavity, the sketch and the surface of the outer contour, the shift hole, the flange sketch, and the boss body. The collection name will be housing_cover. Confirm. Don't forget to save your work.